Okay, so I do want you guys to go back and define domain and range on your own. I'm not going to spend time right now because we're a little bit behind, but I just want you to go back and write those definitions down again. And really the best way is for you to do it like kind of in your own way. So not just copy it word for word, but the more time you spend just going over those things, a bit easier it'll be for you to remember them. So we are going to talk about the difference between a relation and a function today, and that's definitely something you would have done back in Algebra 1 and probably in 8th grade or something, or where you did your pre-algebra stuff. We don't talk about relations a whole bunch because most of the time we think about math, we think about functions because they have certain properties which are helpful to us. But there are other types of equations that aren't functions that we can still do stuff with. Just seems like most of the ones that are really helpful are functions. But one of the ways to tell the difference between a relation and a function is visually with a graph, and that would be involving what's called the vertical line test. And so what that involves is, if you have a graph, that you would draw a vertical line through it and see if the line hits, if it hits more than once. So draw a vertical line through the graph. And if it hits more than once, the graph is not a function. So I'm going to do a couple of little quick sketches for what that would look like, just off to the side here. So if we were to graph something like a circle, so there's an equation that would graph a circle, like we were just talking about equations that would graph parabolas and equations that would graph lines and stuff like that. There's a mathematical equation that would graph a circle. And so if we were to graph a circle and then try to run a vertical line through it, we would notice that that vertical line would hit twice, right? And even if I drew it over here, or if I could find a way to like barely touch the circle on the edge and hit it once, but that's not the point. The point of the vertical line test isn't to try to like cheat it. It's just to see if it happens or not. And so because it hits more than once, this telling us that this circle equation is not a function, okay? If I were to draw something like a parabola, graph a parabola, no matter where I drew a vertical line, I could never find one that would hit more than once, right? And so what that's telling us is that this is a function because those vertical lines only ever hit once. Okay? So that's what the vertical line test tells us, if it's a function or not. The second way, so that's if you have a graph, you can test it with that. The second way is if you're given like a list of points or like data. Like if I had a t-chart or a set of points written out like this, we can look at it and tell if it's a function or not. And so what you're looking for there are repeated inputs. Remember, inputs are your x's with different outputs. That's y. And if you have a repeated x with a different y, that is not a function. So kind of the definition of a function is that every input should have only one output. The idea is that if I plug in 3 into my function, I should get, and the answer is 7. Every time I plug in 3, I should get 7 as the answer. There are equations, like an equation of a circle, where sometimes when I plug in 3, I might get 7, and the other time I plug in 3, I might get -2. Okay. There's nothing wrong with that equation. It's just not a function. Okay. So functions, every time you plug a certain number in, you should always get the same answer back out. Okay. So what we're going to do is use one of those ideas here right off the bat. We're going to check the domain and the range. We're going to follow those rules now that I've described to you guys. We're going to see if it's a function or not. Okay. So remember, domain is my x values. So I'm just going to highlight those real quick. Remember, the two rules are no repeats and from least to greatest. Okay. And I'm going to use those little curly braces. So as I look at those numbers, 8, 5, 9, and 3, I didn't say any number twice. So there are no repeats. So I just got to make sure that I put them in the right order. I'm going to do my best to draw a little curly brace here. Lowest number was 3, 5, then 8, and then 9. Close that up. The range is the y values. So that's my 0, 4, 3, and 8. I didn't repeat any numbers there. I just need to make sure I get them in the right order. 0, 3, 4, and then 8. I had a student in first hour ask if it mattered that like the 3 shows up here and here and the 8 shows up. That doesn't matter at all. When we say no repeats, it's within that group. No repeats allowed. Within this group, there's no repeats allowed. The groups don't really have anything to do with each other. The other thing you can think about domain is this is all of the possible numbers that we can plug in, all of the inputs. This is the numbers that we can get out. These are the answers. Here are the numbers I plug in. Here are the answers I get out. But they're just written in increasing order. They're not like attached. The 3 doesn't go with the 0. The 5 doesn't go with the 3. It's not like that. I'm going to write down the rules again just real quick. No repeats. And then in order. Okay. So since I don't have a graph, I can't use the vertical line test unless I wanted to spend time plotting the points and stuff like that, which would just take time. So what I'm going to do is use the second method. I'm going to look for repeated x values that have different y values. Well, just like we talked about earlier, none of our x values are repeated. So as far as we know, this must be a function because 8 only gives us 0, 5 only gives us 4, 9 only gives us 3, 3 only gives us 8. From what we know about, from the information we're given, we say, yes, this is a function. I'm going to go ahead and explain why. So each input has only one output. Each x has only one y value associated with it. Anything there on A or the vertical line test or method 2 that you guys want to talk about for a doobie? Yeah, Audrey, let's see. Yeah, that's great, Audrey, what you typed there in the chat. So domain for B. So I got 8, -7, 8, 4, right? So I heard that 8 twice, so I'm not going to repeat that as I write it. Lowest number is -7, then a 4, then a single 8. I do those curly braces. The range values, those y values, seen a lot of 8s and 3. So lowest number being 3, and then single 8. And then I want to look to see if this is a function or not. Still want to give you props there, Audrey. Is do we have repeated x values with different y values? So looking at these 2 points here, we see that one time we're plugging in 8 and one getting 8, and then another time we're plugging in 8 getting 3. So this is not a function. I would say 8 has 2 outputs. Anything there you guys want to talk about? Okay. I'd like you guys to do this part on your own. Just describe what discrete and continuous mean to yourself. Just working with those definitions. It's best if you don't just copy them again, but try to reword them a little bit, make a little more connections in your head. So, okay. So now we're going to work with some graphs, and that's what the rest of the problems are, is working with graphs. So we're going to do is find the domain range, talk about if it's discrete or continuous, and if it's a function or not. Okay. Remember, you don't, when you have like 4 questions like this over one like problem, you don't have to answer them in the order. Sometimes they're set up like where it's like, oh, if you do this, then it helps you, if you do part A, it helps you do part B, and this helps you do part C, like that type of thing. But they're not always that way. Sometimes they're just individual questions about this problem, and they don't have to be answered in a certain order. So if there's like a certain part you're like, look at it, you're like, I know the answer to the 3rd question right now, I might as well just answer it, So usually discrete versus continuous is, it's really visual, so it's usually really easy to see. So when I'm looking at this graph and I'm saying, oh, it's just a bunch of dots, right? Well, that means it's discrete. So I might as well just get that out of the way, all right? The domain range for graphs is maybe not as easy with a graph. Domain is X values. So if you're really like a concrete thinker, okay, you like to have things written down and so you can see them and work with them like that, you might need to go and say, okay, this is -3, 4, and this one's -4, -2, and this guy over here is 2, -4. Like you might need to write out the points so you can see those X values and those Y values. It works, okay? And you can have all the points just like the last problems we did. You can go and compare everything like that. Okay, that's a really concrete way of doing it. Unfortunately, you're going to hear me talk about this a lot. The problem with concrete thinking is that it takes longer. So if we can try to move our brains to be more abstract, where we're doing more thinking rather than doing, we can move faster. And so something we can do that's faster here is just look at the X values, right? That's what domain is all about. So here I have that X value at -4. I have another X value at -3. I have another one at -1. I have another one at 0. And I have another one at 2. So those are all the individual X values that I have. And so then I can go and write those out, and they're already written, they're already in order. I catch myself a lot of times just pointing at my iPad, like you guys can see what I'm pointing at. They're already in order, and we've kind of gone, noticed that there weren't any repeats anyways, so it's kind of ready to write. So curly brace, -4, -3, 1, 0, and then 2. And then kind of the same thing with the Y values. I just go back and look at the graph and say, well, where do I have a Y value? So I'm seeing a Y value down here at -4. I have 2 Y values at -2. I have a -1, and then I have a 4. Notice how I started on the bottom of the graph, because we want to go low to high, right? Always the smallest numbers to the bigger numbers. So I started on the bottom. That's the little thing you want to keep track of. With the X's, I started on the left and moved to the right. With the Y's, I started on the bottom and moved to the top. And it's going to be, again, it's going to be something you're going to want to kind of get in your head how to move, what direction to move. May seem a little backwards with the Y values. A lot of times we try to go down to up. Or sorry, a lot of times we try to go up, down. Really should go down to up. So I had -4, -2, and then I had 2 -2s, but I'm only going to write it once. I had a -1, and then I had a 4. Okay. I already know it's discrete, and the last thing I want to check here is if it's a function or not. And so we're going to use the vertical line test to do that. So I basically would think about is, if I ran vertical lines through these, would I ever hit more than 1 point? So there's, I could check it. Nope, hit 1 point. It only hit 1 point, only hit 1 point, only hit 1 point. So all these vertical lines I'm trying are only ever hitting 1 point. So this is a function. So you might be asking, well, what does a not function look like for points? Like if I just have a bunch of points all over. So a graph like this, that's okay, that's okay, that's okay. This guy right here is hitting 2 points. So when you see points that are stacked on top of each other like that, that's not a function. Okay. Anything there with the discrete graph need help with? Things making sense, Jarrett? You there, Jarrett?
Yeah.
Yeah. How about you, June? You doing okay? Okay, cool. All right, so on the other side of that, so the next page there in your notes, a couple more examples. If you look at all 4 of these graphs, one thing you might notice about all of them is that they're all connected, right? They all have lines or curves drawn on them. Okay, so what that kind of tells us that this question here, what I meant by that DC thing is it discrete or continuous? So all 4 of these are continuous. Okay, so again, if that's the easiest question to answer, then might as well answer it right now. Right, so I'm going to go ahead and put that down. I'm just going to abbreviate it on the other ones. Remember, continuous does not mean goes on forever. Like when you look at this one here, it has the arrows at the end. That is not what continuous means. Continuous means that the points are connected. So that point is connected to that point, or there's a whole bunch of points here, 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 like all the way through there. Okay, that's what continuous means. And so just thinking about what that means, like far as the domain and the range, what we've looked at so far as domain and range has just been series of distinct points. We had just a short set of data that represented like 4 or 5 points. The last graph we looked at had, I think, 5 points on it. Well, if you think about the number of points that are on this graph, we actually can't count them because there's so many. I don't know if you guys can see the dots I'm making. There's so many points there, we can't actually count them, right? And so that means we can't just write them down. It would be impossible. Okay, because it's all the little decimals and all the little fractions and stuff like that. We just, it is literally impossible to write them all down. So what do, right? We have to have a different way of talking about it. And I saw a couple of people trying to do this on their domains and ranges from yesterday, which was not appropriate then. If you can list the numbers, then you should. If you can't, then we need a different way of doing it. Okay, and we're never going to have a list of like 50 numbers you have to write down. That's not what we're going to be doing to just mess with you. Okay, when you have a discrete set of data, it'll be short, like 5, 6 numbers at most. Okay. So what we have is something called interval notation. Okay? And what it allows us to describe is all of the numbers between 2 numbers. And you guys would have done something related to inequalities before. Like if I want to talk about all of the numbers that are bigger than 5, right? There's no way for us to write down all the numbers that are bigger than 5. So we just say, hey, x is greater than 5, right? Or if I want to say all the numbers that are less than 2, I say x is less than 2. Or if I want to say all of the numbers that are between 0 and 7, right? There's all of the numbers that are between 0 and 7, right? So we have an old way of doing it, which is using inequalities. What we're going to do is a slightly shorter way of writing that today, which is called interval notation. I'm going to show you what that looks like right now. So domain, right? That's our x values. We want to think of the lowest x value that we have in this problem, which is at -1. I want to think of the highest x value on this problem, which is 3. So all of our x values are between -1 and 3. And so how we write that is -1, comma, 3. Okay. But to keep that so it doesn't just look like a list, like we just wrote lists, right? It had numbers with commas in it, right? But those had the curly braces. So we were saying, hey, here's a list. It has curly braces around it. So that we know that this is also not a list, we use something different. And because, as far as we can tell, it's hitting -1, and it's also hitting -3. It's not telling us any otherwise, so we just have to assume that it is. We put a bracket on those numbers. So those brackets means it hits -1 and then goes all the way up to 3 and hits 3 and stops. It doesn't go just short of it. Okay, so that's what the brackets tell us. It's almost like acting like the equals to, like if I wrote it like that. This notation would be something you guys should be a little bit more familiar with. The compound inequality, right? All of the numbers that are between -1 and 3, but also including -1 and including 3. This is just a shorter way of writing it. This is called interval notation. This is how we're going to write our domains and our ranges for continuous functions, because we can't write all of the numbers between -1 and 3. I'll show you how to do the range. So remember, went with the domain, we went from the left, which is the lowest side, to the right, which is the highest side. With the range, we want to go from the lowest side to the highest side. So we're going to go low to high. Don't go high to low. Okay, so my lowest y value is -3. My highest y value is +1. So the range would be -3 to 1. And again, as far as we can tell, we're hitting -3. So it's going to get a bracket. And as far as we can tell, we're hitting 1. So we're going to get a bracket. So it's kind of your introduction to interval notation. Obviously, this is the first time you've seen that, so your brain might be going, what the devil right now? But is there anything like really not clear about that? We're going to do some more examples to help clear it up. Is there anything right now that you're just completely confounded by as far as the way I did the domain and the range? Good. So since we have a graph, we can use the vertical line test and just thinking about, is there anywhere we could hit a vertical line and hit it more than once? Right, with a graph like this, we're never going to hit it more than once. So this should be a function. I'm going to go ahead and just write that, like how we knew. Yes. Passes the, I'm just going to write VLT, vertical line test. Okay. Then we'll go and do the next example and talk more about the domain and the range. So if we look at the next one to the right there, we already said it's continuous. Might want to think, okay, what's the next easiest question? What if we run the vertical line test again? That seems pretty easy, right? Looks like I'm only ever able to hit it once, so that's going to pass, right? So this is also a function. Oops. Okay. So as I go looking at domain, I want to think domain is x's. That goes left to right. Okay, so I want to start on the left side. I want to see what the lowest value is, right? So as I look at that, it looks like it's right there at -3. And then that right side looks like it's at 1. Okay. But you should notice that there's something different about this graph. It has an open circle here, and over here it has a closed circle. If you go back, to what you did in Algebra 1, pre-algebra with those, like if you graphed an inequality, when you graphed like x is greater than 3, you would have put an 1 through and then drawn a line to the right where it's bigger. If I said, hey, x is greater than or equal to 5, you would have put a closed circle on the 5 and then gone to the right. So a greater than, right, means that we're purely greater than. We can't actually get to 3. Gave us an open circle, and the greater than or equal to or the less than or equal to gave us that closed circle because we could actually include that number. So it's the same thing here on these graphs. What this open circle means is that the graph doesn't actually reach -3. It just gets right up next to it. So our lowest number is actually, -2.99999. Okay. But obviously we can't write out all the nines we would need to. So all we do is put -3 like we did before. And we're going to put the 1 like we did before. And since we've got that closed circle on the 1, it's going to get that bracket. But since the open circle is going to be just a parenthesis. Okay, so I kind of labeled that there, like why we use a parenthesis, why we use a bracket. Okay. So if it doesn't quite reach the number, we want to use that parenthesis there. If it does hit the number, we want to use the bracket there. Okay. Otherwise, we're saying it's all of the numbers between -3 and 1, including 1, but not including -3. Okay, that's what that means. So we're able to write that whole phrase that I just said with quite a few words with 5 symbols. Okay, so that's why we have the interval notation to really shorten down the writing. Okay, but you have to spend time reading it correctly. Anything you guys want to talk about there with the domain? All right. With the range, again, I want to start on the bottom of the graph, and then move to the top, low to high. So I look at the lowest part of this graph. Looks like I have a couple points that are hitting at -4. And then I'll look at the top of the graph. Oops. I have this point here that's hitting at 0, and then this point here that's getting really close to 0.
Hey, Mr. Baker.
Hey, what?
It's 223.
It sure is. You're right. Appreciate that.
Yeah.
I'll finish this up. Okay, so the -4 being the lowest value, we're hitting that -4. Okay, so that's going to get a bracket. The highest value, so we have that point that's right below 0, but then we have another point that's at 0. So the 0 is the highest point, and so we're actually hitting that 0 at this spot. So it'll be also a bracket. So what this function is, or what the domain range is telling us, is that we can plug in numbers from -3 to 1, including 1, and all of the answers we will get will be between -4 and 0, including -4 and 0. That's what all this means. Possible numbers I can plug in, possible answers. This is a long list of numbers, right? These are long lists of numbers. We're writing an interval notation. So, as you can see, I'm going to stop recording.